Good evening, sir. I am L. Navinayak from CSMB section, first BTech second semester, CA2 Assignment Engineering Physics. My topic name is ionic polarization. Let's we discuss about ionic polarization. Introduction to ionic polarization. The ionic polarization is a phenomenon but occurs in ionic compounds. It involves the displacements of positive and negative ions in response to an external electric field. This movement results in the creation of a net dipole moment in the material. What is ionic polarization? The polarization of an ionic bond means the destroyer of the electron could a anion towards cation. Polarization of an ionic bond results bond covalence character. The basic concept of a dipole moment. Yeah, a dipole moment is a measure of the separation of positive and negative charges within a molecular or material in ionic polarization. The dipole moment is created due to the movement of ions. The magnitude of the dipole moment is directly proportional to the ionic charges and the distance between charges. The types of dipole magnets: permanent dipole, induced dipole, temporary dipole. The organic of ionic polarization. The organic ionic polarizations arises from the asymmetry in the distribution of positive and negative charges in an ionic solid. When an external electric field is applied, the positive and negative ions are displaced in opposite directions. The displacement results in the alignment of dipoles along the direction of the field, leading to polarization. Ionic polarization: in ionic lattice, the positive ions are displaced in the direction of an applied field, while the negative ions are displaced in the opposite directions, giving a resultant approved dipole moment to the whole body. The two pictures: electric fields, crystal structure, and ionic polarizations. The crystal structure of ionic solids plays a crucial role in determining its polarization behavior. In materials with a non-centrosymmetric crystal structure, such as a zinc oxide, the ionic polarization is more pronounced. The arrangement of ions in the crystal lattice polarizations. Ferroelectric materials and ionic polarizations. Ferroelectric materials exhibit spontaneous polarization even in the absence of an external field. This spontaneous polarization is a result of the alignment of dipoles in the material. The presence of ionic polarization in ferroelectrics give rise to ionic properties such as hysteresis and domain information. The dielectric constant and ionic polarization discuss. The dielectric constant of a material is a measure of its ability to store electric energy under applied electric field. Ionic polarization contributes significantly to the dielectric constant of materials. The presence of mobiles ions exchanges the polarization response in dielectric properties of the material. Non-polarized material, electrical polarized material, unpolarized atomic elements, polarized atomic elements. The frequency depend on ionic polarizations. The response of materials to an external electric field varies with the frequency of the electric field. A low frequency ionic polarization dominates the dielectric behavior. At high frequency cues, other mechanisms such as electronic and dipole polarization become more prominent. Yeah, applications of ionic polarization. Capacitors. Ionic polarization plays a crucial role in the functioning of capacitors. In electrolytic capacitors, the formation of a double layer at the electrode electrolyte interference extends the ionic polarization. This phenomenon allows for the storage of large amount of charge and energy in capacitors. The polarization capacitors, these are diagram for examples. Influence of the temperature on ionic polarization. Temperature has a significant impact on the mobility of ions and hence on the ionic polarization. At its high temperatures, the movement of ions is more pronounced, leading to increased polarization. However, excessive thermal energy can disrupt the crystal structure and reduce the effectiveness of polarization. Ionic polarization, biological systems. Discuss. Ionic polarization is essential for various biological processes such as nerve condition and muscle contraction. In nerve cells, the movement of ion across cell membranes generates electrical signals. The polarization and depolarization of cell membranes are circular for the transmission of nerve impulses. The next topic, measurement technique used for ionic polarization. Techniques such as a dielectric spectroscopy and impedance spectroscopy are commonly used to study ionic polarization. A dielectric spectroscopy measures the dielectric properties of materials as a function of frequency. Impedance spectroscopy provides information about the conductivity and relaxation process associated with the ionic polarization. The challenges in ionic polarization. Yeah, controlling ionic polarization in materials process challenges due to factors such as crystal defects and impurities. The presence of mobile ions can lead to leakage currents and instability in devices. Strategies such as doping and interface engineering are employed to the enhance and control ionic polarization. Future trends ionic polarization research. Future research in ionic polarization aims to develop mobile materials with tailored polarization properties. Advances in matter technology and material science will enable the design of materials with enhanced ionic conductivity and polarization. Understanding the fundamental mechanisms of ionic polarization will lead to the development of next generation electronic and energy storage devices. A summary of key points. Ionic polarization is the displacement of positive and negative ions in response to an external electric field. It leads to the creation of net dipole moment in materials, affecting their dielectric and electric properties. The crystal structure, temperature, and frequency of the applied field influence the extent of ionic polarization in materials. What is ionic polarization? For the C examples, thank you. Thank you for attention and interest is learning about ionic polarization. Thank you, sir.